afternoon. I'm Emily Munter, and I'm a habitat person working for the U.S. Fish and Wildlife Service in our fisheries office in Soldotna. And kind of my role with the Fish and Wildlife Service is primarily working with private landowners who have an interest in improving, restoring, rehabilitating habitat on their property. So we can go out and meet with folks and identify opportunities for improving habitat on private land. And annually, I work with Jessica Johnson with the Department of Fish and Game to host a streambank workshop, and it's historically has been on the Kenai River. And we actually have a 2-day workshop annually where we present the information that Lucas and myself and others will be talking about today. So I'm taking, and we have like an 8-hour classroom portion and then a 1-day field portion. So I'm taking, roughly 8 hours of material and condensing it into less than 1 hour for you. And this material is really geared towards private landowners. So not knowing what our composition would be here today for participants, it's relatively layman's. But I'm going to give you a little bit of information about hydrology, erosion, kind of our basic tenets or goals for streambank rehabilitation, and then I'll provide a few snippets of information about the techniques that we'll be installing when we all go to Silverking Campground here in an hour or two. So I'd like to start by sharing a brief video with you and why do rivers meander.
Compared to the whitewater streams that tumble down mountainsides, the meandering rivers of the plains may seem tame and lazy. But mountain streams are corralled by the steep walled valleys they carve. Their courses are literally set in stone. Out on the open plains, those stony walls give way to soft soil, allowing rivers to shift their banks and set their own ever-changing courses to the sea. Courses that almost never run straight. At least not for long, because all it takes to turn a straight stretch of river into a bendy one is a little disturbance and a lot of time. And in nature, there's plenty of both. Say, for example, that a muskrat burrows herself a den in one bank of a stream. Her tunnels make for a cozy home, but they also weaken the bank, which eventually begins to crumble and slump into the stream. Water rushes into the newly formed hollow, sweeping away loose dirt and making the hollow even hollower, which lets the water rush a little faster and sweep away a little more dirt, and so on and so on. As more of the stream's flow is diverted into the deepening hole on one bank and away from the other side of the channel, the flow there weakens and slows. And since slow-moving water can't carry the sand-sized particles that fast-moving water can, the dirt drops to the bottom and builds up to make the water there even shallower and slower, and then keeps accumulating until it becomes new land on the inside bank. Meanwhile, the fast-moving water near the outside bank sweeps out of the curve with enough momentum to carry it across the channel and slam it into the other side, where it starts to carve another curve, and then another, and then another, and then another. The wider the stream, the longer it takes the slingshotting current to reach the other side, and the greater the downstream distance to the next curve. In fact, measurements of meandering streams all over the world reveal a strikingly regular pattern. The length of one S-shaped meander tends to be about 6 times the width of the channel. So little tiny meandering streams tend to look just like miniature versions of their bigger relatives. As long as nothing gets in the way of a river's meandering, its curves will continue to grow curvier and curvier until they loop around and bumble into themselves. When that happens, the river's channel follows the straighter path downhill, leaving behind a crescent-shaped remnant called an oxbow lake.
Or a billabong.
O un lago en herradura.
Ou un bras mort.
We have lots of names for these lakes, since they can occur pretty much anywhere liquid flows, or used to. Which brings up an interesting question. What do the Martians call them?
So essentially rivers are more than just conduits for water. And Luke did a great job of describing a lot of aspects of this. But rivers move sediment, they would move woody debris and nutrients, and they move these things from the terrestrial environment to the ocean. And along their longitudinal profile, or along a river's length, typically you can divide rivers up into 3 sections, with considering that the headwaters is where most of the most, but not all, but most of the sediment input derives. The transfer zone is where sediment is deposited, resuspended, reworked, and then carried further downstream into the depositional zone, such as where we sit, and that's where typically sediment is deposited and forms floodplains. So the takeaway message here, and the video did a great job of describing this, is that you have different flow rates within your river systems, and within a depositional zone such as where we sit, riparian vegetation plays a little bit of a bigger role in channel stability versus your transfer zone or your headwater zone of rivers, where there's also a big influence on the terrain. So when you're in a meandering portion of a river, your fastest flows are going to be on the outside bends of those meanders. And so it's when you are considering maybe what an erosional process is occurring on a property, think about the juxtaposition of the property in the context of where property sits on the meanders. Your erosion tends to take place on outside bends, and your deposition take place on inside bends. So as much as possible, if you can restrict your access to the river on the inside of those bends, you're going to have less of an effect if you're trying to access river in other areas. And also, to the greatest extent possible, try to avoid developments on the outside bends. Even if the views from the cut bank are outstanding, it's wise to avoid putting developments on those areas, because we do know that rivers move, and that's a natural process. So now that I've kind of touched on where erosion can occur, I want to talk a little bit about why. Erosion occurs, a formal term for the process is called sediment entrainment. But entrainment essentially is the process by which the surface sediment gets suspended in fluid. This is driven by a number of different factors, including your flow velocities, your water depth, the sediment size, and the vegetation type and density, and also root structure type of the vegetation next to your stream. And once your sediment becomes entrained, there's a number of processes that can take place, and really the names of those processes are less important than knowing that it's driven by the factors that I mentioned just on the previous slide. It's also driven by soil type. Like, for example, if you have more of a clay component in your soils, sediment entrainment is much slower than if you have gravel or coarse soil composition in your stream bank, and then that way your sediment entrainment can happen much more rapidly. The bottom line is rivers move, and I think we're all pretty well aware of this, and we're well aware of this taking place on the Anchor also. It's kind of a noteworthy example. This is on Montana Creek up by Talkeetna, and this shows the stream movement between 2012 and 2018. Wow. There were some areas where, so the blue is 2012 and the green is 2018. And there were some areas where the stream moved up to 130 feet just in that 6-year period.
But that's all. That could be all natural, from not necessarily erosion.
Absolutely.
Yeah, man-made. Right?
Yep. That's where I'm headed.
Okay.
So this averaged 21 feet a year. Kind of a closer example of natural rate of movement is below Ski Lac Lake on the Kenai, and that averages anywhere from 1 to 5 feet a year. I've got a couple examples in hand from the Yukon, where it ranged from like 13 to 40 feet, and then even examples of like big rivers like the Mississippi River has moved 630 feet just in one event, just because rivers move. That's what they do naturally. Here's a couple photos of the Anchor, which I found were pretty interesting. I don't have like the distances, but this is the North Fork. I don't know if folks have seen these before, but it shows a rate of movement between 1950 in the blue and 2003 in the yellow. And then the photo On the right is a rate of movement from 75 to 84 on the main stem of the anchor. And again, it's rivers move, and this is a naturally driven process.
Although the one on the right, I think you could argue that there's that road ended up sort of truncating. When the river moved, it's really flattened out there, right? So it's actually no longer really moving naturally
In a
across
natural
that
path.
path.
Good point. So if you take away anything from these last few slides, is I want you to take away the fact that erosion is not a dirty word. It's not even a 4-letter word, though some people probably say those words when they have it occurring on their property. But erosional processes are incredibly important, and they're important for river health, they're important for aquatic species, they're important for the terrestrial species that are using the area adjacent to the river. And so natural erosion is typically not a process that we attempt to or strive to stop. I'm not going to spend very much time here because Luke really hit home some of these, but woody debris in rivers is important, and natural stream movement provides woody debris input into streams, which is important for salmon habitat, most definitely. Natural cut banks, like why this may look ugly, it's actually important because it's an important sediment input into a stream. It replenishes sediment that otherwise would be lost as the river flows to the ocean. So this is replenishing those important sediments, gravels, cobbles into stream systems. And again, it's a natural process. It's not one that we want to stop. But as I mentioned earlier, it's not advisable to put your house at the top of that bank.
We might mention, Emily, that if the sediment source is stopped, then the river's going to cut more of the channel.
Yeah, thank you for bringing that up. Yeah, rivers, you can consider them to be sediment hungry. So if there's not a source of suspended sediment, they seek that out. And if it's not available in situations like this, rivers try to or tend to pick that sediment up from the bottom. And then you can have a downcutting of your stream. So a study from 95 kind of demonstrated that banks without riparian vegetation were much more likely to erode during flood events. This study documented 5 times as likely to erode, and of those, a major bank erosion was 30 times more likely to take place along stream banks that weren't vegetated as opposed to those that were. So when you're standing along a stream bank trying to consider what is happening along a stream bank, you need to think about if your erosion is natural erosion or human caused or human helped. Up to this point, I've primarily talked about natural erosion. The lower photo is an example of a human caused or human helped situation. And so the erosion will be exacerbated by what's taken place on this property.